All right, welcome to part 5 of chapter 2. We're going to talk about graphical techniques here, and it really alludes to something I talked about earlier, that velocity is the slope of the position versus time graph. Acceleration is the slope of the velocity versus time graph. All right, so slope is nothing other than rise over run. Right, if we have this straight line, y equals mx plus b. Right, so we have the straight line y equals mx plus b. The slope of this line is that m, which is the change in y over the change in x. Now, remember that form, y is mx plus b. If we go back to our linear equations, right? Pardon me. X equals vt plus x naught. So this is the same form. All right, and under constant acceleration, v equals at plus v naught, the same form. So we're talking about the slope, right? And if it's just a straight line, it's pretty straightforward. The slope is all we need. So now, if we talk about velocity, here we have displacement versus time. Well, this curves as things go along, right? Velocity is not constant. If velocity were constant, this would be a straight line. So velocity is not constant. But we can take pieces of it and we can look at the slope at those pieces by drawing a little tangent and doing our triangle, right? And we can get a delta x over delta t for little pieces of this. And when we do that, we end up with the average velocity over that little time period, right? That's the velocity at each of these points. If we do the same thing with the velocity versus time, and we just put in triangles here and there to measure the slope at different points, what we're mapping out is the acceleration, right? So if we've got displacement versus time and we look at the slope at different points, we're mapping out velocity versus time. And if we look at velocity versus time and we look at the slope at various points, we're mapping out acceleration versus time. Right? So here, the acceleration is higher down here because the velocity is changing more. And then when you get up here, the acceleration is going almost to zero. Velocity is not changing much. Here, velocity is lower because x is not changing as fast. Here, the velocity is higher because x is changing faster. This gives us the ability, by understanding the graphical techniques, gives us the ability to have an intuitive feel for these graphs, right? Get an intuitive feel for acceleration's higher, acceleration's going to zero, velocity is lower, velocity increases, means there's acceleration here, right? Because the velocity is increasing, we're accelerating. And that is the fundamental bit about graphical techniques and understanding graphs. And you will see problems like this on standardized exams all the time. All right, that's it for chapter 2.